Alrighty, so I think it's time for more advanced uses of our deferred API. So one of the things I wanted to make sure worked from the start was chaining multiple deferreds together, multiple asynchronous operations being chained together, so that from the call side itself, it looks like kind of one thing is happening, but in turn, this whole sequence of either parallel or sequential operations are happening in the background somewhere, be it a different thread, being it a different fiber, being it waiting, loading something, out of process communication, network communication, anything like that. We want to turn all of those, the concept of sort of waiting for something to happen into a single object that makes our code a lot cleaner. Unfortunately, that's going to require some relatively advanced stuff in order to put it together, particularly in regards to how we're going to be using generics and delegates and overload resolution. So what I'm going to do here is, you guys don't have to follow along for this example, but you can if you want to. We're going to be building a sort of micro framework that's going to be very similar to what we're going to be building inside of Photon. But really the justification of why I put together a handful of these operations that I did, such as join and then, was to facilitate us being able to write a version of this in Photon itself. So putting together something really light for you guys, I just want to show you guys what the end goal is and all of that fun stuff. So I'm going to start off with creating some base methods. And now I won't implement these methods yet, but I want to show you guys how they can sort of be composed together in a way that should make sense. So we're going to start off with the concept of loading a level. So I'm going to say deferred, or how about joining a game or starting a game? Start game. And let's go ahead and just give that a public so it's not lopsided. And for starting a game, we want to have a level name and an int game ID, right? Now, when starting the game, we have a handful of things that we want to do first. So the first thing we want to do is load the level. So I'm going to say private static deferred load level string level name, and he's just going to return null for now. We'll flesh this guy out and the next few people here out in a minute. The next thing we want to do, in addition to loading a level, we might want to, well, join the actual game. So we can do join game, which will require a game ID, which will also return a deferred. But it's actually going to return a deferred of string. And, well, I can make this example a little bit better by creating a dummy class up here called game state. And game state will just wrap a string. String state, just a public property, and we'll do our formatting operators. So we have our game state, and when we join the game, we want to only join the game after we've loaded a level, but we want, once we've joined the game, to retrieve our game state out of it so that we can load up all the actors and all that fun stuff. Again, this is all hypothetical, really just basic skeleton code here, just to show you guys in a kind of sort of pseudo real-world example how this stuff would work. So then we'll have a private static. After we join a game, we need to load our state in. So we'll have a static deferred, and this won't return anything, but it will be called load state and string state. So we have these three distinct operations here: loading our level, joining the game, and loading state. And we want them all to happen sequentially. So this start game method, I'm going to show you guys how we can compose these multiple asynchronous operations together using the API that we put together. I do think that I'm missing something in one of my classes, but we'll fix that in a second. So the first thing we want to do is load the level, passing in level name. After we've loaded the level, let's do a then. We want to join the game. So I'll say join game, game ID. After we join the game, we want to load the state. So then we're going to say then, but we need to retrieve the state that the join game method gave us. Remember, join game returns a deferred of game state. So I'll say state goes into this load state state.result. Or whoops, this should be game state, shouldn't it be? Not a string. There we go. And that's the method I'm missing, so ignore the squiggles for now. And we'll do, we'll just leave it there. So this is our basic operation. We load the level, then we join the game, then we load the state. Let's go ahead and fix this little squiggly thingy right here first. So I'm going to exit full screen, and inside of deferred, I'm going to have to add a new overload. See, the overload that I'm missing is an overload that receives, it's a then call that receives a deferred of type t, but then returns a deferred of not type t. So we're going to have to make sure that we have that put in here somewhere. I think the, let's see, the place we would put that in is deferred of 1, or deferred of t result, and down here at the bottom. So I'm going to say deferred, this then will only return a normal deferred. It'll accept a function that takes a deferred of t result, so it takes a deferred that returns a value. And it returns nothing. So actually, why am I doing that? Well, it returns a deferred. And we'll call this next, and we'll return null. So to be clear, this then takes in a function that takes in a deferred that has a value to it, and returns a deferred that needs to happen next, basically. So now going back into this, we'll notice that our code now compiles. So now we've taken these 3 things that might do whatever they want. They might go and they might hit network resources, they might load stuff off the file system, they might do some processing in a different thread, and so on and so on. And we've composed them together into this single operation called start game. And now that they're composed, I can go ahead and say start game level 1, game ID of 123, and I can say on success, game started, and on fail, game didn't start, and then, oops, I probably should have that there, and then, oops, I should also accept a deferred here so that I can extract the error message. And there we go. So now we've composed all these 3 asynchronous operations into this one start game method. And then on start game, we don't care how many asynchronous things are happening behind the scenes, what order they happen, or whatever. All we care is that they all happen. And if they succeed, we say game started. And if they fail, we say they didn't start based off that error. Okay, so what I'm going to do now is I'm going to put together a little micro framework real fast. It's going to be a little bit of code, and I'll type it out really quickly, hopefully. And it's going to it's going to mimic the little micro framework I'm going to use to integrate with Photon. So I'm going to go ahead and call this, I don't know. I can't call it, well, I don't want to call it Async. We can just call it framework, I guess. It's gonna be a static class. It's nothing fancy. So private static. We're gonna do a helper function first. Private static void sleep, which will take in an int wait for milliseconds, an action. Oh, come on. Action and an action string on fail, and this will be exactly like what we had before in the last, or almost exactly like before in the last one. This sleep method really just. I don't even should really call it sleep. I should do perform async op. Or no. I'm going to keep this asleep. Okay, so then I'm going to say new thread, and his thread start is simply going to first it's going to do thread.sleep milliseconds to wait for milliseconds. We're going to try action. And we're going to catch an exception if it happens, and if it does, we're going to say on fail e.message. So, yeah, and then, of course, at the end, we're going to say on start, or do start. So this is our sleep method. I'm just going to move him off to the side. He's just a thing there to pretend that we're doing something that takes a while. So now what we're going to do is we're going to wrap this sleep method up with 4 other methods. So let me write the signatures of those 4 methods first. We're going to do public deferred of do async operation in wait for milliseconds, and the first one is going to take in an action operation. So this is the simplest of our deferreds. The next one is I'm going to have a deferred do async operation that takes in an int wait for milliseconds, but then takes in a func of deferred. So this one is interesting. This will allow us to do an asynchronous operation, but then return a continuation. It will allow us to return a new deferred that we will have to wait for its completion before this main deferred gets completed. So next up, we're going to have let's see here, another deferred of t, and this, or t result, why not keep it, do a sync operation, and this will have wait for milliseconds, followed by a func t result operation. So this is a fun one right here. This takes in a method that performs some sort of asynchronous operation somehow, but then when that method returns, it returns with the result of what I want to set this deferred to. And then finally, we'll do deferred of t result, do a sync operation of t result, and then we'll do a func of deferred of t result. This method is analogous to this method. So what it's going to do is you can return a deferred that returns a result, and then it'll eventually set the result of this deferred to it when the deferred that you return succeeds. These four methods hopefully will become more obvious in a moment here when I show their uses, but let's go ahead and implement them real fast. Implementing them is pretty straightforward. Our basic one is var def equals new deferred, return def, and then we'll do our wait, what did I call that? Sleep. Wait for milliseconds. Our action is simply going to be invoke the operation and then set def to set result true null. Should probably indent this so our indentation gets back on track like that. And then our fail is simply going to say def.setResult false error. And there we go. Now I'm going to go ahead and copy and paste this here because it's pretty much the same thing. The only difference is right here, we're going to say var next equals, because notice this operation returns a deferred. And then instead of saying def.setResult, so watch this. This is going to be cool. Def.join next. So instead of us resolving this deferred that was returned, we then set it so that the next deferred, when it gets finished, will then set the result of this deferred. So this is how we're chaining different operations. This one is similar, so I'm just going to copy and paste. Of course, we're instantiating a deferred of t result this time. And this the thing that this returns is not next, it's result. And for here, we say a set result true null result. So here what I'm doing is I'm invoking this operation that returns a value, and I'm then setting, invoking it, getting its result, then setting the deferred to that when it returns. And I'm getting a, oh, I didn't make these static, did I? I'm stupid. There we go. And then we have this one. Now, this guy is going to be very similar to the other guys. So we'll have def t result. Now, the difference is we need to do a join here instead. So we instead of a set result. So we need to do a def.join operation or result. And we'll change this from result to next. So for this guy, we return a synchronous operation that returns a result, and then we only complete the deferred that was returned by that when that next operation happens. Now that we have these guys all done, so only 81 lines of code, not that bad. I'll scroll through it slowly for a second. Now that we have those done, we can now put together our fake load level, join game, and load state. So basically what these guys are going to do is on load level, I'm going to say write line loading level name. So the whole purpose of this sort of framework right here is to make it so we never have to deal with deferreds directly. So we can write some really straightforward code. So all I have to do here is say return framework dot do a synchronous operation for a second. And then for loading the level, what I need to do is I need to load the initial level, but then I also need to load the user interface. So I'm going to say write line level loaded loading UI. And then I'm going to say return framework dot do a sync operation Let's load the UI in 500 milliseconds, just because why not? So now I hope you can see how we were chaining our asynchronous operations, but without having to deal with the actual deferred API. So this doAsync operation is going to be using this overload right here. So it's going to be invoking this method after 1 second. It'll be invoking this method, and then it'll be getting the deferred that was returned back, which is this guy right here, and it's going to be joining the deferred that was returned with the deferred that we got back. This doAsync operation, however, is the simplest one. All it does is it invokes this operation, which is this block right here, and then sets the result. But because they're chained like this, when I set this deferred's result will then be set. All right, so what about joining a game? So for joining a game, we need to return a game state. So I'm going to say right line, joining game ID. And I'm going to say return framework doAsync operation. Let's say it takes 1 second to join the game. Now, well, wait a sec. Actually, the first thing I'm going to do is I'm going to connect to the server. So connect to server. And then we'll do an async operation. And then inside of this, we'll say right line connected to server, getting game ID. And then in here, we'll say return framework.doAsync operation. Let's say it takes 300 milliseconds to get the game state. And then I'm simply going to return new game state. And I'm going to do a write line. So it's basically like magic. We're threading through this game state that we received after doing a nested asynchronous call, and we're threading it all the way back to whoever invoked join game. Without the caller of join game even caring where the game state came from, be it network or disk or whatever, or how long it took to get there. All right, so now we have load state. For load state, we can just use, I'll just do something simple. Right line, loading state, return framework, do asynchronous operation. Let's say it takes 100 milliseconds to load the state. And then I'll just be like, right line state loaded state. There we go. So that's our example. These async operations being chained, that's really the goal of what we're doing here. And it's not a lot of code. The reason that I'm sort of showing you guys this now, and we'll practically be doing the same thing in a framework here in the next couple of videos when we integrate this with Photon. But the reason I'm showing you this now is because I really want to at least have people get an idea of how these types are threaded through each other. It's interesting how much generic type inference is helping us right now with all these different types and the way the C# type resolution system works, which is quite brilliant and allows us to do all these things. I mean, look at all these doAsync operations. Half of them aren't even... So this is a different one than this one. That's the same one as this one, but not that one, and so on. And just by cleverly tying together type parameters, it allows us to do this. Anyway, I hope the code at least makes sense. Now, of course, it's not going to run yet, but it will run after a minimal amount of implementation. So I'm just going to scroll up here, then scroll down slowly, and then we can get to actually implementing this. All right, as far as implementation goes, we're going to hop over into deferred. And so for this guy, our first thing that I want to go ahead and do is do our join method. The join method is very, very, very simple. Simply do next on always set result. Or rather, sorry, I'm dumb. It's next on always def goes into set result, def is valid, def error. So all we're doing is we're literally saying the next deferred that you're asking us about, when it's done, set ourselves to its result. Okay, then gets a little bit more complicated. So we need to create a new deferred here. I told you we were going to instantiate a bunch of these things. And we'll go ahead and return it. And then what I want to do is on always, so when we're done, I want to go ahead and say def, or sorry, this one will be return def, just to make it clear that this is the return def and that this def is our inner def. And then I'm going to say, if not def is valid, then the return def, actually, return def, I don't like that. I'm calling it then. Then has a much better ring to it. Oh, right, but then I have a then there. Let's call this next. All right. So, if def is not valid, as in if we failed, then what I want to do is I want to say next set result false error, and then I want to return. Otherwise, I want to say next.join, then invoke. So what we're doing here is we're creating a new deferred that we're returning. And then we're on ourselves. If we fail, we tell that new deferred that it failed and the chain is broken. If we succeed, then what we do is we say, then join on whatever is returned by then. So then go out and execute that thing that you wanted to execute, return that new deferred, and then join on that new deferred. Which, if you look at join, is going to take that next and put an event handler on it to set its result to this. So it's kind of convoluted the way things are kind of being used right here. I mean, in this then function, we have a func that returns a deferred, and we are a deferred. So there's that. But this is how we properly thread through our sequence. Okay, so for the next then, it's practically the same thing. So I'm just going to copy and paste. The only difference is that this then returns a deferred of t, so that we have to instantiate a deferred of t here instead of a deferred. Alrighty, so now we have to go and jump into our deferred of t result and do our join and our two thens. So our join is going to be similar. It's simply going to be next on always. And for this next, we have a deferred of t result. So I'm going to say def goes into. Then I'm going to say set result, def is valid, def error, def result. So that's our basic join. Then our thens are going to be very similar. So I'm going to say var next equals new deferred of type t result 2. Now this is an interesting thing. Whoops, I didn't want to call this next. I wanted to call this then. Is that what I did here? Yeah, that's what I did there. And so I'm changing that parameter just to keep everything consistent, because there's so many variables being thrown around right now. We want to make sure that all these methods are as consistent as possible. Now, this then is very, very, very interesting. This then allows you to basically change the result type of a chain. It allows you to say, okay, this deferred returns this result. Now I want you, after you're done, to execute another deferred, but the other deferred returns another result of another type. That's why we have tResult2 here as a generic type parameter. So now in this next, I'm going to say on always, and on always, I use def as that, right? Yep. On always def. If not def is valid, do our normal thing, next set result false def error, and then return. So basically what we did before. And then the next thing is basically going to be the same. It's going to be, we're going to want to say next.join on the invocation of then. And we're going to want to pass in, what do we want to pass in? We need a deferred of t result, so we need to pass in def. So def is the parameter we're passing into this function. And the reason we do that is so that the then function can access the result. And then as far as this then isn't that exciting either. I'm just going to go ahead and copy and paste this. And the difference is that we simply return a next of an empty deferred. a deferred without a result. And that's it. About 100 lines of code there. About 164, so 200 lines of code. I know we're missing a couple methods, but that's okay. We'll write them when we do the Photon integration. So now I'm going to scroll down slowly on our deferred of t result, so you guys can take a look at kind of how that got put together. And let's jump into program and let's hit F5 and see what happens. Probably an exception. Loading level 1, level loaded, loading UI. Oh, well, it worked. Let's show an example of this then. Or sorry, of this then, because I really like this then. I don't think it's even being used anywhere. No, it's not. So for that then, what you would do to use it would be, let's say that this game state, you wanted to transform this game state into a different object. So let's say private static string game state to string game state. And in this guy, state, this guy, all we're going to do is we're going to return deferred.success state.toString. And of course, we need it to be a deferred of string. So this is an example of a non-asynchronous operation. We're simply returning deferred.success. We're not doing any sort of callbacks or waits or anything like that. So now what I could do is I could say, so who gives me my state? My state comes from join game. So let's say I want to do join game 1, 2, 3, and then I want to say dot then. After we join the game, I want to say game state to string, passing in def.result, and then I want to say on success. Now look at the type here for on success. On success is now a deferred of string. So what happened here is this then returned a different type of deferred that translated the value. And this success now has access to that translated value. So I can say write line def.result, and you'll notice def.result is a string. And if I go ahead and hit F5, you'll eventually see... well, actually, let me make this a little bit more obvious here. You'll notice right there. There it is. Thought I was going crazy for a second. You'll notice that we do indeed invoke that method and we return the state properly. So that then is very, very cool because it allows you to change the type of the pipeline as you're executing. There's more interesting use cases here. I know, especially people who aren't familiar very well with generics might be confused. I encourage people to sit here and play around with it and kind of get a feel for what's going on. There's so much going on behind everything right now, and it's very interesting. It's very powerful, but it definitely is worth taking the time to learn a little bit about generics. So what if I wanted to what if I wanted to have access to the state and the game state to string? Well, I can chain it like this. I can simply return that. I'm breaking it out to make it easier to read. And then I can say on success, and I can say console or write line original state def.result. And then new state is going to be, let's call this state string. So here's an example of how we can kind of combine two invocations of a deferred with a result into one and have access to both of their return values. And it'll do the same thing. It'll process in the exact same order, but the way the scoping works here is you'll be able to access both those parameters. Not something that happens a whole very often, but it does happen sometimes that you need that, and I just wanted to show you guys that it does work. Let's throw a couple errors. Let's throw an error on getting game. So just to show this off, Check that out. So notice that at any point if exception was thrown, it gets caught by the doAsync operation method. And when it gets caught, the deferred in the pipeline at that point threw an exception and gets set to invalid. And we get the onFail callback. And so it's important to note, though, is it'll only invoke the onFails that have happened since the pipeline, at that pipeline at that position. So, for example, if I come out here to start game, I can do load level onFail right here. This onFail will only be invoked if load level fails. Whereas this onFail... Ooh, I just found something I need to add. This onFail will only be invoked if join game or load level fails, but will not be invoked if load state fails. And I'm pretty sure I can fix that error by jumping down to my deferred of 1 or deferred of t result and jumping up to my onFail and creating a second overload that takes in just an action. Now this will require a new. Because the type parameters don't differ at all on this callback, I need to redefine the base onFail. So what exactly was going on there? This might be an interesting thing for people who aren't so familiar with generics and overload resolution. Notice how my onFail method that doesn't take a deferred. So this onFail method just takes normal action. It returns a deferred, and this is on the base deferred type. Now, if I didn't have a secondary onFail function here, notice how I get an error down here. I get an error because I basically short-circuited the typed deferred. I did an onFail method, but I returned a naked deferred. Now, the deferred without a result is still the same object, because the deferred with a result inherits from the deferred without a result. But by short-circuiting that type that type parameter propagation, the next method no longer has access to the methods that are available on the deferred of t result. So the solution is to do method hiding, where if I invoke onFail with an action that does not accept a parameter on a deferred of t result, make sure that we return a deferred of t result and not a normal deferred. Well, I think that's about it. I hope you guys had fun looking at this. I know I spent a lot of time working on this and putting this together for you guys, or showing or going through the code, but I really want to drive home how important it is. And once we get moved over to the Photon project, what we're going to have to do is replace our entire IRPC method implementation with using this. And once we're done with that, then things will be awesome. So I guess we'll do that in the next video, and we'll see you guys then.